Alright, hi again. So we just learned about complex numbers, which are in the form of a plus bi. So complex numbers, the form a plus bi, where a is the real part and bi is your imaginary part. So let's look at simplifying imaginary numbers. So the task is here, so example 2, write the complex number, the square root of -9 plus 6, in the form a plus bi. Alright, so let's write this number in the form a plus bi. So a is our real part, this is the real part, and then bi is our imaginary, so let's put im. So I'm going to write the 6 out first, that'll be our real. And then I need to write the imaginary part in the form bi. So let's look at negative root 9, or sorry, square root of root 9, square root of negative root 9. Yeah, wait. The square root of negative 9. And I'm going to rewrite it as the square root of -1 times 9, which breaks out into -1, square root of -1 times the square root of 9. This becomes I, square root of 9 is 3, or 3i. So this is my imaginary part here. So I'm going to write this over here, 6 plus 3i. So there's our answer. So we've written a complex number in the form a plus bi. Let's look at another one. So example, write the complex number, the square root of -18 plus 7 in the form, I'm going to turn this into a plus bi. Okay, so first thing, the 7 is real, so I'm going to write that down here. Now I need to rewrite root -18 as an imaginary, so in the form of bi. So the square root of -18 breaks out into -1 times 18, which turns into the square root of -1 times the square root of 18, which becomes 1, or sorry, I. And then root 18 goes into 9 times 2. The 9 I can pull out, that becomes 3i root 2. So this is my imaginary part, so I'm going to take this and pull it back here, 3i root 2. There's the answer for that one. Okay, so it's really helpful to know how to break down a square root. If you could remember just to use a factor tree, that will help you out there. Okay, so there's that. Now let's look at writing. So just as we can graph normal numbers, coordinates, we can graph complex numbers on the complex plane. So little weird here, but it looks like this. This is developed by a German guy named Euler, E-U-L-E-R, Euler. So we have two axes. We have the real axis down here. This will be just like our x-axis. This is where you're going to graph all your real numbers. 1, 2, 3, 4, 5. -1, -2, -3, -4, -5. And then this axis is going to be your imaginary axis. This axis here is imaginary. So on here you're going to graph all your numbers in the form bi. So I have I, 2i, 3i, 4i, 5i. Down here we have the negatives, so -i, -2i, -3i, -4i, -5i. So this is complex axis where we can graph numbers in the form a plus bi. So let's look at our first number that we want to graph, 3 minus 4i. So we have a real part and a negative part. My real part will be the 3, so this is real. So this goes down on the real axis. So I'm going to go to the right 3 on the real axis. And then I have my imaginary part, negative 4i. So this is my imaginary part. So this is im. So this is going to go down 4 on the imaginary axis. Now where these two go, that will be my point. So my coordinate 3 minus 4i appears here on the complex plane. So we've gone down 4i and we've gone to the right 3. Let's look at finding the distance of coordinates on the complex plane from the origin. So you might see something called finding the absolute value of a number. So the absolute value of a complex number is its distance from the origin. Now we can use, so let's look real fast before I get there. I'll take the number, so example, find 5i, the absolute value of 5i. So if I look at this real fast on the complex number plane, 5i appears up here on the y-axis. This has a distance. The distance, I can just count down 5 units. The distance here is 5. So the absolute value of 5i is equal to 5. It's 5 units away from the origin. Another example, find the absolute value of negative 4i. So if I look at this on the number plane, it's gone down 4 units. So my distance here, remember distance is always going to be an absolute value, so it's always going to be a positive number, so the distance is going to be 4. So the absolute value of negative 4i is equal to 4. Alright, cool. Now, another example over here. Find the absolute value of 3 minus 4i. Okay, so we can use the Pythagorean theorem for this. Okay, so I'm going to draw a real small little complex plane here. I'm going to head right 3, right, because that's our first, this is like our x. I'm going to go to the right 3, 1, 2, 3. And then I'm going to go down 4, 1, 2, 3, 4. So we're down here. So I'm going to make a little triangle. So we're just looking at distance units here. This is 3, and this is negative 4. So just like with a triangle, if I want to find the hypotenuse, I would do 3 squared plus negative 4 squared equals 25. And this will be c squared. So to get the hypotenuse, I would take the square root of 25, which is 5. So the absolute distance of 3 minus 4i on the complex number plane is 5 units. Okay, another example with this. Find the absolute value, or the absolute distance, of 6 minus 4i. Well, I can just do 6 squared plus negative 4 squared. That's 36 plus 16, so that's 52. And then I would take the square root of that. Remember, this is all the square root. Square root of 52 breaks down into, let's see, 26 times 2, 26 times 2, and then that's 13 times 4. Yeah. So then that becomes 2 root 13. Alright, so I'm going to stop this video and then do another one.